Out there in the cold, silent depths of the solar system, far beyond the familiar glow of the sun, lies a world shrouded in shadows, a place so strange, so eerily out of reach, that it's earned the nickname, the anti-Pluto. This is Orcus, a dwarf planet lurking in the Kuiper Belt, a realm of ice, rock, and secrets waiting to be uncovered. Picture a frozen wasteland, its surface reflecting barely any light, its orbit out of sync with the rest of the solar system. What makes this distant world so peculiar? Why does it seem to mirror Pluto in some ways, yet defy explanation in others? And what are the 25 unsolved mysteries that have left scientists scratching their heads for decades? From its bizarre orbital dance to the unexplained dark patches staining its icy crust, Orcus doesn't just challenge our understanding of the solar system, it dares us to question everything we thought we knew about the outer limits of our cosmic neighborhood. Some believe it could hold clues to the origins of the solar system itself, while others whisper about even stranger possibilities lurking beneath its frozen shell. What if this dwarf planet isn't just a relic of the past, but a key to something far more profound? Tonight, we're diving deep into the enigma of Orcus, unraveling its 25 most chilling mysteries one by one. We'll explore the theories, the contradictions, and the lingering questions that make this distant world one of the most fascinating and unsettling places in the Kuiper Belt. So strap in, because this journey isn't just about a dwarf planet. It's about the limits of human knowledge, the persistent drive to uncover the unknown, and the eerie sense that some secrets, no matter how hard we search, might never fully be revealed. Are you ready to confront the mysteries of Orcus? Let's begin. At first glance, Orcus could almost be Pluto's long-lost twin. Both are nearly the same size, with diameters hovering around 900 kilometers. Both dance in a peculiar orbital rhythm called resonance, completing 2 laps around the Sun for every 3 Neptune makes. And just like Pluto's iconic moon Charon, Orcus has its own silent partner, Vanth, a moon so large it blurs the line between companion and co-ruler. Yet the moment we look closer, the similarities shatter. While Pluto's surface gleams with reflective ice, casting back almost half the sunlight that hits it, Orcus sits in a gloom of its own making. Its albedo, the scientific term for how much light it reflects, is startlingly low, absorbing most of the feeble sunlight that reaches it. Even more baffling, spectroscopic readings reveal patches of material that don't match anything we've seen on Pluto. Some areas hint at organic compounds, the kind that form in the presence of ancient, complex chemistry. Others show traces of ammonia, a volatile substance rarely stable on such cold surfaces. Theories swirl like solar winds around these contradictions. Could Orcus have been struck by a cataclysmic impact, one that stripped away brighter surface ices and left behind darker, deeper layers? Or is something stranger at work beneath its crust, tidal heating from Vanth's gravitational tug, or even residual warmth from radioactive elements locked in its core? The most tantalizing possibility, Orcus might be a time capsule, preserving chemistry from the solar system's violent infancy in ways Pluto never did. Every answer only peels back another layer of mystery. Why did these 2 worlds, born from the same swirling disk of debris, end up so fundamentally different? The truth might rewrite not just our understanding of Orcus, but of how all dwarf planets evolve in the frozen dark. But the strangeness of Orcus doesn't stop at its dark, chemically chaotic surface. Peer into its craters, those ancient scars left by cosmic collisions, and you'll find something that defies explanation. Some of them glow, not with the dull reflection of ice, but with a faint, eerie luminescence that telescopes have barely managed to capture. It's as if hidden beneath those frozen basins, some unknown energy source flickers in the perpetual night. What could possibly cause this phenomenon on a world so far from the sun's warmth? One leading theory points to radioactive minerals trapped in the crust. Elements like thorium or uranium, decaying over billions of years, might emit just enough radiation to excite frozen gases, creating a subtle, ghostly light. Another possibility, cryovolcanoes, not the fiery mountains of Earth, but slow, icy geysers spewing ammonia-rich slurries that could react chemically with surface materials, producing brief, eerie flashes. Then there's the wilder speculation. Could these glowing patches be remnants of some long-lost technology? The idea stretches credibility, but in a solar system where we've found moon-sized objects with underground oceans, ruling anything out entirely feels naive. Still, scientists remain grounded. The most plausible explanations are natural, even if they're no less extraordinary. Yet even these theories crumble under scrutiny. Radioactive minerals should distribute evenly, not cluster in specific craters. Cryovolcanic activity would require far more internal heat than Orcus should possess. So the mystery deepens. Could tidal forces from Vanth be flexing the dwarf planet's core, generating just enough warmth for bizarre chemical reactions? Or are we seeing something entirely new, a form of cold luminescence unique to the outer solar system's extreme conditions? Every hypothesis leaves gaps, and that's what makes Orcus so compelling. It's not just another frozen rock, it's a puzzle box, each layer revealing contradictions that push the boundaries of what we think is possible, and the glowing craters. They're just the beginning. Of all the cosmic oddities surrounding Orcus, none unsettle astronomers quite like its moon Vanth, not just for what it is, but for how it moves. Most moons in the solar system trace elliptical orbits, their paths stretched into ovals by the gravitational tug of war between planet and satellite. But Vanth breaks all the rules. It circles Orcus in a near-perfect circle, locked into an orbit so precise it feels almost engineered. Even stranger. Its movement is flawlessly synchronized with Orcus's rotation, always showing the same face to its dwarf planet partner, as if an invisible hand set them spinning in perfect harmony. This level of orbital precision is unheard of for objects their size, especially in the chaotic sprawl of the Kuiper Belt. Take Pluto and Charon. Their mutual dance is a waltz of gravitational give and take, their barycenter, the point they both orbit, floating between them in space. But Vanth's orbit suggests something even more improbable. Either this moon formed in place from the debris of a colossal impact billions of years ago, preserving an eerily exact trajectory, or it was captured by Orcus's gravity under circumstances so freakishly precise they border on statistical impossibility. The impact theory holds some weight. When NASA New Horizons revealed Pluto's heart-shaped basin, scientists realized such colossal collisions could birth moons like Charon from splattered debris. Yet Vanth's composition throws a wrench in that idea. Spectral analysis shows it's far darker and richer in carbonaceous material than Orcus itself, more like a captured Kuiper Belt object than a fragment of its parent body. That leaves astronomers puzzling over how a captured moon could settle into such a circular, synchronized orbit without tearing itself apart or spiraling away. Compare Vanth to other Kuiper Belt binaries like the similarly sized pair Haumea and Hioka, and the anomalies multiply. Haumea's moons follow messy, eccentric paths, their orbits tilted at odd angles. Yet Vanth's path is so unnervingly neat. It's as if some unseen force sanded away all the rough edges. Could tidal forces have reshaped its orbit over eons? Maybe, but simulations suggest that would require Vanth to be far more malleable, its interior partially molten, which contradicts its icy, rigid appearance. The most unsettling possibility, Vanth's orbit isn't just a quirk of physics. Some researchers quietly speculate that a third, unseen body, a long-lost moon or a stealthy Kuiper Belt interloper might have nudged Vanth into place eons ago, then vanished without a trace. Others wonder if we're seeing the handiwork of a rare cosmic resonance, where the gravitational whispers of Neptune or Pluto sculpted Vanth's path like a sculptor refining clay. Whatever the truth, Vanth's impossible orbit is more than a curiosity. It's a challenge to our understanding of how celestial mechanics work in the solar system's frozen fringes. If such precise alignments can emerge naturally, what other rules of astrophysics might be waiting to be rewritten? And if they can't, what or who might have stacked the cosmic deck? One of the most puzzling absences on Orcus is something that should by all rights be there: an atmosphere. Pluto, its near twin in size and distance from the Sun, clings to a tenuous but detectable shroud of nitrogen, methane, and carbon monoxide. Even smaller Kuiper Belt objects like Makemake sport fleeting atmospheric hazes when they drift closest to the Sun. Yet Orcus, despite every similarity, shows no trace of gaseous envelopment. It's as if the dwarf planet is holding its breath, refusing to exhale into the void. So where did its atmosphere go? The first possibility is the simplest: maybe it never had one. If Orcus formed in a particularly dry or volatile poor region of the early solar system, it could have started life as a barren ice ball, lacking the lighter compounds that typically sublimate into gas when warmed. But this explanation doesn't quite hold up. Spectroscopic studies reveal ammonia hydrates and organic molecules on its surface compounds that, under even faint solar heating, should release gases. Unless, of course, something locked them away. That leads to the second theory. Orcus once had an atmosphere but lost it. Solar winds, the relentless stream of charged particles from the Sun, could have stripped away any nascent gases over billions of years. But Pluto endures the same cosmic weather with its atmosphere intact, albeit fluctuating. The difference might come down to gravity. Orcus's mass is slightly less than Pluto's, meaning its gravitational grip would be weaker, potentially too weak to hold onto escaping molecules. Yet this still feels incomplete. Even Eris, another dwarf planet smaller than Pluto, shows signs of a temporary atmosphere at certain points in its orbit. Why is Orcus the exception? The most tantalizing answer lies beneath the surface. Imagine a world where the atmosphere isn't lost but trapped. Orcus's frigid crust, thicker and darker than Pluto's, could act like a cryogenic seal, bottling up volatiles in a subterranean reservoir. Occasional cryovolcanic vents might briefly puncture this frozen lid, releasing plumes of gas before they freeze back into the ice. If true, we might be seeing Orcus in a quiet phase, its atmosphere lying dormant until some future shift in temperature or tidal stress wakes it. The implications are staggering. A buried atmosphere could mean pockets of liquid water or ammonia-rich slush beneath the ice environments where exotic chemistry, or even the faintest whispers of probiotic life, might persist. It would also make Orcus a ticking clock. One day, a close pass to the Sun or a gravitational nudge from Vanth might crack the icy vault wide open, transforming this silent world into a temporary comet, spewing gases and dust into the void. Until then, the mystery lingers. Is Orcus truly airless or just waiting for its moment to breathe? Even in the grainy, low-resolution images we have of Orcus, some features stand out immediately, not just for their strangeness but for their unsettling precision. Spanning vast stretches of the dwarf planet's surface are geometric patterns, a labyrinth of intersecting lines and near-perfect rectangular shapes that look less like natural formations and more like the remnants of some colossal alien blueprint. These aren't the chaotic cracks of a freezing world or the splatter of ancient impacts. They're grids unnervingly symmetrical, as if drawn with a ruler across the ice. The simplest explanation points to tectonic stress. On Earth, similar patterns emerge when shifting plates stretch or compress brittle crust, creating fracture networks like those in dried mudflats. Orcus, with its icy shell, could experience something analogous: thermal contractions from extreme temperature swings, or tidal flexing from Vanth's gravitational pull, splitting the surface into geometric shards. But there's a problem. The patterns on Orcus appear too uniform, too evenly spaced, with angles too sharp for most natural processes. Even Pluto's famed spider terrain, a network of fractures radiating from a single point, looks organic by comparison. Then there's the eerie precedent of Mars. Decades ago, the so-called face on Mars, a trick of light and shadow in Viking orbiter images, ignited decades of speculation about artificial structures. Later high-resolution photos revealed it as a mere mesa, yet the fascination lingered. Could Orcus's grids be another case of pareidolia, our brains imposing order on random geology? Or is there something more profound at work? A handful of researchers dare to voice a wilder idea. What if these patterns are relics of something artificial? The notion isn't as far-fetched as it sounds. On Earth, ancient civilizations built geoglyphs like the Nazca lines, massive designs only visible from above. Could some long-vanished intelligence have left similar markers on Orcus, knowing they'd only be spotted by beings advanced enough to reach the Kuiper Belt? The vast timescales of the solar system leave room for staggering possibilities, yet the truth likely lies somewhere between the mundane and the extraordinary. Recent studies of Jupiter's moon, Europa, reveal similar geometric fractures caused by the slow churn of subsurface oceans, a reminder that nature can craft precision we mistake for design. If Orcus hides a buried ocean or slushy mantle, its icy shell might be cracking under hidden currents, sculpting these cryptic patterns over eons. But until we send a probe to orbit this frozen enigma, the grids remain an open question. Are they the scars of a dynamic, shifting world or something far stranger? One thing's certain, in the silent dark of the Kuiper Belt, Orcus seems to be whispering secrets we're only beginning to hear. If there's one thing astronomers expect from a dwarf planet, it's noise, not sound, but the faint hum of radio waves and thermal energy, the kind of signatures even the coldest objects emit simply by existing. Yet Orcus defies expectations once again. Unlike Pluto, which crackles with faint radio emissions and infrared warmth, Orcus sits in near total silence. No detectable heat seeps from its icy shell, no radio waves ripple from its surface. It's as if the dwarf planet has been muted, its natural signals swallowed by the void. This radio silence isn't just unusual, it's borderline unnatural. Objects in the Kuiper Belt, no matter how frozen, should emit some thermal radiation as residual heat from their formation or the decay of radioactive elements inside them. Even Sedna, a solitary world 3 times farther out than Orcus, broadcasts a faint infrared glow. So why is Orcus so eerily quiet? One theory points to an ultra-dense core. Imagine a planetary vault, its interior packed with heavy metals or rocks so tightly woven that it acts like a cosmic insulator, trapping heat and energy deep within. If Orcus formed from a collision that compressed its core beyond typical densities, it could explain the absence of outward radiation, but there's a catch. A core that dense would warp the orbits of nearby objects, tugging at Vanth with measurable force. Yet the moon's path remains pristine, showing no signs of such gravitational interference. That leaves scientists grappling with alternatives. Could Orcus's icy crust be unusually thick, acting like a thermos to keep its warmth locked away? Or is something actively absorbing or masking its emissions? Here's where the speculation turns spine-tingling. On Earth, stealth technology works by deflecting or absorbing radar waves, rendering objects invisible to detection. Could Orcus, by some wild twist of physics or something else, be doing the same on a planetary scale? The idea isn't as far-fetched as it sounds. Certain minerals, like magnetite-rich composites, naturally dampen electromagnetic signals. If Orcus's surface is laced with such materials, either by chance or some ancient geologic upheaval, it might explain the silence. Then there's the elephant in the room, the remote possibility of artificial intervention. While mainstream science dismisses the notion, A vocal minority points to the unsettling precision of Orcus's other anomalies, its geometric grids, Vanth's perfect orbit, as pieces of a larger, inexplicable puzzle. If a civilization ever sought to hide something in plain sight, the Kuiper Belt, with its vast distances and minimal scrutiny, would be the ideal place. Of course, Occam's razor suggests a simpler answer. Orcus might just be a cosmic oddity, a quirk of composition and history that makes it uniquely stealthy. But in a universe where pulsars beam like lighthouses and gas giants blaze with internal heat, a world that refuses to whisper even the faintest signal feels less like an accident and more like a mystery waiting to be cracked. Until we land a probe on its surface or peer beneath its ice, the silence of Orcus will remain one of its most unnerving riddles. The more we study Vanth, the more its story feels incomplete, like a puzzle missing a crucial piece. Astronomers have crunched the numbers and something doesn't add up. The moon's orbit, while eerily perfect, carries subtle gravitational hiccups, tiny wobbles that suggest it wasn't always the only satellite circling Orcus. Hidden in the math is a ghost, the echo of a second moon, long since vanished. Imagine this scene from the distant past. Orcus, still cooling from its violent formation, hosts not one but two moons, Vanth and a smaller sibling. The pair dance in unstable harmony until a gravitational nudge from Neptune or a passing Kuiper Belt object tips the balance. In this chaos, the smaller moon is ripped away, ejected into the void or torn apart by tidal forces. The debris from this cosmic breakup could have formed a fleeting ring system, like those around Saturn, before dispersing or raining down onto Orcus's surface. Evidence for this drama hides in the present. Vanth's unusually dark composition, so different from Orcus itself, might be a clue. If the second moon was richer in carbonaceous material, its shattered remains could have coated Vanth like cosmic soot, explaining the moon's inky appearance. Even more compelling, the faint, uneven distribution of dust particles detected in Orcus's vicinity, a possible remnant of that ancient debris field. But why would a second moon vanish so completely? The answer lies in the instability of binary systems. Pluto's smaller moons, like Styx and Kerberos, are thought to be survivors of a similar upheaval. Gravitational simulations show that with three bodies in play, Orcus, Vanth, and a hypothetical sibling chaos is inevitable. The slightest imbalance could send the smaller moon spiraling away, leaving Vanth behind as the sole witness. The consequences of this lost moon theory ripple outward. If true, Orcus's surface might be littered with foreign material from the collision fragments that could explain those mysterious dark patches and geometric fractures. Even Vanth's orbit, seemingly too precise to be natural, might owe its perfection to the gravitational vacuum left by its absent twin. The universe has a way of settling into new equilibriums after chaos, and Orcus's strange harmony could be the aftermath of a celestial divorce billions of years in the making. Yet the most haunting question remains: where is the debris now? If a ring system once existed, its traces would be faint but not undetectable. Future missions might spot chemical anomalies in Orcus's ice or faint arcs of dust lingering in its orbit. Until then, the twin moons theory lingers in the realm of might have been a shadow in the math, a whisper from a time when Orcus's sky held more than one silent sentinel. The strangest mysteries aren't always the ones we can see. Sometimes they lurk in the gaps between expectation and reality, hidden in the silent ticking of cosmic clocks. Consider this: when sunlight bounces off Orcus and travels back to Earth, it arrives late. Not by hours or even seconds, but by milliseconds, a delay so slight you'd miss it if you blinked, yet consistent enough to set astronomers on edge. According to every calculation, the light's journey should take a precise amount of time, dictated by the unwavering speed of light and the known distance between Orcus and Earth. But the numbers don't match. The light is sluggish, as if something unseen is holding it back. At first, scientists dismissed it as a measurement glitch, a blip in the data caused by Earth's atmosphere or an instrument calibration error. But when multiple telescopes across multiple observations kept recording the same discrepancy, the whispers began. Could there be something fundamentally wrong with our understanding of this distant world? One possibility leans on Einstein's shadow, relativity. Massive objects warp spacetime, bending light's path and slowing its progress like a car navigating a winding mountain road. If Orcus harbors hidden mass, a dense core, a cluster of dark matter, or even a miniature black hole from the early solar system, it could twist spacetime just enough to delay the light's return. Yet the math resists simplicity. For Orcus to warp light detectably, it would need a gravitational pull far stronger than its size suggests. That's where the theories take a turn. Some researchers propose an unseen companion, not a moon, but a compact, monstrous sibling, like a neutron star or a primordial black hole orbiting Orcus in secrecy. Others wonder if the Kuiper Belt itself is to blame. What if the space around Orcus isn't as empty as we think? A diffuse haze of dark matter, a relic from the solar system's birth, could linger there, imperceptible to telescopes but massive enough to tug at passing light. Then there's the outlier hypothesis, the one that sends shivers down spines. What if the delay isn't caused by mass at all, but by something altering the light itself? Quantum physics hints at exotic particles or fields that could interact with photons, subtly sapping their energy. On Earth, experiments have slowed light to a crawl using ultra-cold gases or crystalline structures. Could Orcus's icy crust or some deeper, stranger layer be doing the same naturally? Of course, skepticism remains. Critics argue that the delay could still stem from mundane factors. A misjudged distance, a fluctuation in solar radiation pressure, or even the faint drag of interplanetary dust. But with each passing observation, the anomaly persists, a tiny hiccup in the data that refuses to vanish. And that's the heart of the mystery. In the grand clockwork of the cosmos, Orcus seems to be ticking out of sync. Whether the answer lies in hidden mass, undiscovered physics, or something beyond our current imagination, one thing is clear: this dwarf planet isn't just a frozen rock. It's a stopwatch counting down to a revelation we're only beginning to grasp. Among the frosty plains and shadowed valleys of Orcus, some of the most striking features aren't the geometric grids or the eerie craters, they're the streaks. Not just any streaks, but vivid, blood-red gashes staining the otherwise pale surface like wounds in the ice. These rusty rivulets cut across the landscape in jagged patterns, concentrated in tight clusters rather than spreading uniformly. And unlike Pluto's broad, faded reddish patches believed to come from tholins, complex organic molecules cooked by sunlight, these streaks burn brighter, almost violently scarlet, as if whatever painted them is far more potent. So what creates such lurid stains in a world so distant from the sun's warmth? One possibility points to cryovolcanism, not the explosive geysers of Enceladus, but slower, oozing vents belching slurries of ammonia, water, and organic compounds. When these mixtures hit the surface, the brutal cold would freeze them instantly, but not before chemical reactions could produce deep red hues. The localized nature of the streaks suggests these plumes aren't global events, but isolated eruptions like bleeding fissures in a frozen corpse. Yet there's a problem with this theory. Cryovolcanic activity requires heat, and Orcus, by all accounts, should be geologically dead. Unless Vanth's gravitational pull is flexing its core far more than we realize, or radioactive decay is generating unexpected pockets of warmth, the energy for such eruptions shouldn't exist. That leads to a darker alternative. The red isn't fresh. It could be residue from an ancient cataclysm, a colossal impact that splattered organic, rich material across the surface, where it baked under eons of cosmic radiation into these burning streaks. The strangest clue, though, lies in the color itself. On Pluto, tholins create a muted brick red tint spread evenly over vast regions. Orcus's streaks are sharper, almost artificial in their intensity. Some researchers speculate they might contain iron-rich minerals or even exotic carbon chains not seen elsewhere in the Kuiper Belt. If true, it would mean Orcus's chemistry is stranger and potentially more volatile than we ever imagined. Then there's the unsettling thought no one wants to voice but everyone considers. Could these streaks be seasonal? On Mars, dark streaks known as recurring slope lineae appear and vanish with temperature shifts, hinting at briny flows. Orcus is too cold for liquid water, but if its ices contain pockets of ammonia or methane, even slight orbital changes might trigger brief thaws, releasing bursts of crimson sludge before refreezing. For now, the streaks remain a haunting enigma. Are they signs of a hidden, churning interior, the scars of a forgotten impact, or something even rarer, a chemical fingerprint unlike anything else in the solar system? Until a probe finally peers closely at Orcus's stained surface, these bloody gashes will keep their secrets, a cryptic reminder that even in the darkest corners of space, nature finds ways to shock us. When spacecraft map a world's gravity, they expect subtle variations, gentle dips and swells reflecting mountains, valleys, and underground layers, but Orcus doesn't do subtle. Data from distant flybys and orbital calculations reveal gravitational hiccups so extreme they shouldn't exist on a world this small. Some regions pull with unexpected ferocity, as if weighted by chunks of neutron star. Others exert barely any tug at all, like voids where the planet's mass simply vanishes. What could cause such violent inconsistencies? Start with the obvious impacts. A colossal asteroid strike could have punched deep into Orcus's crust, leaving behind caverns where subsurface ice vaporized or collapsed. But that doesn't explain the ultra-dense zones unless the impactor was something unimaginably heavy, like a fragment of a white dwarf star. Even then, the distribution defies logic. These anomalies aren't scattered randomly. They cluster in tight, geometric arrangements, mirroring the eerie surface grids we've already seen. That's where the theories turn speculative. One radical paper proposed that Orcus might contain fragments of a Dyson sphere, hypothetical megastructures built by advanced civilizations to harness a star's energy. The idea sounds ripped from sci-fi, but the math is chillingly plausible. If such a structure shattered eons ago, its ultra-dense panels could have peppered the Kuiper Belt. A shard embedded in Orcus would explain both the gravity spikes and the unnatural surface patterns. Skeptics counter with alternatives. Maybe Orcus swallowed a swarm of iron-rich asteroids, their metallic cores still sitting undigested in its gut. Or perhaps tidal forces from Vanth warped its interior, compressing some regions while stretching others thin. Yet none of these fully account for the sheer extremity of the readings. The most unsettling possibility, we're seeing traces of quantum-locked matter, exotic particles predicted by string theory, so dense they warp space-time on microscopic scales. If such material exists inside Orcus, even in tiny amounts, it would rewrite our understanding of planetary formation. Until a probe gets close enough to map these anomalies in detail, their origins remain a cosmic riddle. But one thing's certain, Orcus isn't just a ball of ice. It's a patchwork of contradictions, some impossibly heavy, some impossibly light, and whatever's causing them, the implications could shake astrophysics to its core. Out in the frozen reaches of the solar system, where the sun is little more than a distant flicker, Orcus spins with eerie precision, not just on its axis, but in perfect lockstep with the giant planet Neptune. For every 2 orbits Neptune completes around the sun, Orcus finishes exactly 1 rotation on its axis, as if some cosmic metronome is keeping time across billions of kilometers. This isn't just a curious alignment, it's a gravitational riddle wrapped in layers of impossibility. How could a dwarf planet so small and distant synchronize its spin with a gas giant it never directly interacts with? The obvious answer is tidal locking, a phenomenon we see when moons like Earth's match their rotation to their orbit. always showing the same face to their parent planet. But Orcus isn't Neptune's moon. The two worlds are separated by a yawning void, their gravitational influence on each other practically negligible. Yet the synchronization persists, precise down to fractions of a second over millennia. Some astronomers argue for a delicate chain of resonances, a celestial game of telephone where Neptune's gravity tugs on other Kuiper Belt objects, which in turn nudge Orcus into rhythm. It's a fragile explanation, though. Resonances this precise usually require direct interaction or a shared history, like Pluto's orbital dance with Neptune. But Orcus shows no signs of ever having been close enough to the giant planet for such a relationship to form. Then there's the wild card, Vanth. Could Orcus's moon be acting as a middleman, translating Neptune's distant whispers into tangible forces? Tidal interactions between Orcus and Vanth might theoretically transfer energy in ways that subtly adjust the dwarf planet's spin. But simulations show this would require Vanth to be far more massive or closer than it is, leaving the theory dangling in the realm of almost but not quite. The most unsettling possibility, this synchronization isn't natural at all. Imagine a scenario where some ancient, unknown force, a passing star, a rogue planet, or even an artificial intervention tweaked Orcus's rotation eons ago, setting it into this uncanny rhythm. Far-fetched, absolutely, but in a solar system where every conventional explanation falls short, the line between impossibility and inevitability starts to blur. Until we uncover the true mechanism behind this cosmic clockwork, one thing is clear: Orcus doesn't just orbit the sun. It moves to a hidden beat, one that echoes across the void, tying it to Neptune in a dance we're only beginning to hear. Deep in the frozen reaches of the Kuiper Belt, where temperatures hover just a few dozen degrees above absolute zero, ice shouldn't just sit there, it should vanish. Not melt, but sublimate, jumping straight from solid to gas as the feeble warmth of the distant sun coaxes molecules loose. Yet Orcus defies the rules once again. Its surface ice clings stubbornly to its frozen state, refusing to sublimate even where every calculation says it should. This isn't just unusual, it's as if the dwarf planet has found a way to cheat thermodynamics itself. The puzzle deepens when you compare Orcus to its neighbors. Pluto's nitrogen ice dances between phases, puffing into a wispy atmosphere when it nears the sun. Even smaller Kuiper Belt objects like Haumea show seasonal sublimation, their surfaces reshaped by the slow escape of ices. But Orcus, its frosts stay locked in place as though trapped under some invisible seal. One explanation points to exotic ice phases, structures so tightly bonded, they resist sublimation even in the vacuum of space. On Earth, we know ice mostly as the fragile, hexagonal crystals in your freezer. But under extreme pressure and cold, water molecules can arrange into forms like Ice 2 or Ice 9 No, not the apocalyptic variant from Kurt Vonnegut's novels. These ultra-stable configurations might coat Orcus, their molecular lattices shrugging off the sun's weak attempts to pry them apart. Then there's the wild card, heat. Not the kind you'd feel, but just enough to tip the balance between frozen and fleeting. If Orcus's interior hides even a whisper of warmth from radioactive decay, tidal friction with Vanth, or residual energy from its formation, it could create a delicate equilibrium. Picture a freezer with a broken seal, its contents hovering right at the edge of thawing but never quite crossing the line. On Orcus, that slight warmth might nudge surface ices just enough to prevent sublimation without actually melting them, leaving the crust perpetually on the brink of change but never surrendering to it. The most tantalizing possibility, though, lies in chemistry. Ammonia, detected in Orcus's surface ice, acts as a cosmic antifreeze when mixed with water. Even traces of it can lower the freezing point dramatically, creating a slushy matrix that resists both sublimation and brittle fracturing. Add methane or nitrogen into the mix, and you've got a recipe for ice that behaves more like tar, sticky, stubborn, and eerily resilient against the void. Yet none of these theories fully explain the sheer defiance of Orcus's ice. If exotic phases are at work, why don't we see them elsewhere in the Kuiper Belt? If hidden heat is the culprit, why doesn't it warp Vanth's orbit or trigger cryovolcanism? The answer might lie in a combination of factors, a perfect storm of cold, chemistry, and geology that makes Orcus unique. Or perhaps we're glimpsing something far stranger, a snapshot of the solar system's infancy, preserved in ice that never got the memo to fade away. Whatever the truth, one thing's clear: Orcus isn't just another frozen rock. It's a laboratory for extremes, a place where the ordinary rules of physics seem to bend. And until we land a probe on its enigmatic surface, its stubborn, unmeltable ice will remain one of the most baffling riddles in the dark beyond Neptune. In every other corner of the solar system, craters tell their stories through shadows, deep, jagged contours that carve dramatic contrasts between light and dark. But Orcus plays by different rules. Some of its craters, captured in the faintest high-resolution images we have, show no shadows at all. Their basins lie flat and featureless, as if someone smoothed them with a cosmic eraser, scrubbing away the very depth that defines impact scars. It's not a trick of the light or an imaging glitch. These shadowless pits appear consistently, clustered in specific regions, defying the basic physics of how light interacts with terrain. One explanation points to the unusual properties of Orcus's ice. Most cratered worlds, like Earth's moon or Mercury, are rocky, with surfaces that cast sharp shadows. But if Orcus's crust is laced with highly reflective, finely textured ice crystals, similar to fresh snowfall on Earth, light could scatter in unpredictable ways, filling in shadows with diffuse glare. Imagine shining a flashlight onto a field of crushed diamonds. The beams would bounce wildly, softening every edge. On Orcus, this effect might be amplified by exotic ices we've yet to identify, turning profound depressions into optical illusions. Yet even this theory stumbles. If light-scattering ice were the culprit, why don't all of Orcus's craters vanish equally? Some regions show perfectly normal shadows, while others remain eerily flat. That inconsistency has led to more speculative ideas. Could these craters be filled with something translucent, like glassy impact melt or frozen gases so clear they bend light around them? Or might they house structures, natural or otherwise, that actively diffuse incoming light to camouflage their depths? The most unsettling possibility involves tampering. On Earth, advanced stealth technology manipulates light to render objects invisible. If something or someone once sought to hide the contents of these craters, altering their reflective properties would be a brutally effective method. Of course, nature rarely needs a helping hand to create strangeness. Subsurface heating, cryovolcanic resurfacing, or even the slow creep of ultra-dense ices could theoretically smooth these craters from within, leaving them ghostly and shallow. Until we peer closer, the shadowless craters remain a paradox. Are they tricks of optics, scars half-healed by hidden forces, or something far more deliberate? In the silent dark of the Kuiper Belt, Orcus seems determined to keep its secrets not in darkness, but in light itself. Astronomers mapping Orcus have stumbled upon a phenomenon so bizarre, it defies every expectation of how planetary surfaces behave. Between observations, entire mountains seem to vanish, peaks that were clearly visible in one set of images simply gone the next, as if the landscape itself is shifting beneath the gaze of our telescopes. These aren't minor changes in shadow or lighting angles. These are towering formations, some estimated to rise several kilometers high, disappearing without a trace over spans as short as a few Earth years. The first instinct is to blame the data. Could these vanishing acts be glitches in telescopic imaging, artifacts of distant observation? Yet the same anomalies appear across multiple instruments, from Earth-based observatories to deep space probes. The consistency is unsettling. If it's not an error, what could make mountains dissolve on a world where temperatures hover near absolute zero, freezing geology into near-permanent stasis? One explanation points to volatile frost cycles. On Pluto, nitrogen and methane ices sublimate and recondense with seasonal shifts, subtly reshaping surface features. But Orcus is far colder and more stable. For frost to erase mountains, it would need to accumulate in unimaginable quantities, burying entire ridges under kilometers of ice, a process requiring energy Orcus simply doesn't receive from the feeble sunlight. Unless, of course, the frost isn't coming from above. If cryovolcanic plumes erupt sporadically, they could blanket regions in fresh ice, camouflaging topography under uniform sheets. Yet even this falls short. Such eruptions would leave visible fissures or flow patterns, none of which appear near the vanished mountains. Then there's the spine-chilling possibility of shape-shifting terrain. On Earth, glaciers creep and calve under gravitational stress. Could Orcus's ice behave similarly, but on an accelerated scale? Certain exotic ice phases under extreme pressure and cold can exhibit plastic flow, oozing like molasses over geologic time. If tidal forces from Vanth or hidden heat sources destabilize subsurface layers, entire landmasses might slump, collapse, or even migrate across the surface. Imagine a mountain range made not of rock but of hyper-dense ice, slowly dissolving into valleys like sand through an hourglass. The most radical theory, though, involves something far more alien: transient geology. On Saturn's moon, Titan, methane rain carves rivers that appear and vanish. Could Orcus host an equivalent process where volatile compounds briefly liquefy under rare conditions, only to refreeze into new forms? It's a stretch, but in the Kuiper Belt, where conventional rules crumble, even the wildest ideas deserve a hearing. Until a mission reaches Orcus, these vanishing mountains will remain cosmic sleights of hand. Are they tricks of optics, monuments to an unstable world, or evidence of forces we've yet to imagine? One thing's certain: on this dwarf planet, the ground beneath your feet might not stay ground for long. Among all of Orcus's enigmas, few are as fleeting or as frustrating as the whispers of unseen companions. Astronomers have caught glimpses of them, faint smudges in deep field images that suggest tiny moons darting through the darkness alongside Vanth. But every time telescopes focus closer, these phantom satellites dissolve like smoke, leaving no trace in follow-up observations. Are we seeing cosmic mirages, or is something far stranger hiding in plain sight? The first hint came from a grainy Hubble image 2 decades ago, a pale speck glinting briefly near Orcus's limb, then vanishing in subsequent frames. At the time, astronomers dismissed it as a passing Kuiper Belt object or a camera artifact. But then the pattern repeated. In 2009, the Herschel Space Infrared Observatory detected an infrared blip where no moon should be. In 2016, Earth-based telescopes in Chile logged a flicker of reflected light moving in sync with Orcus's rotation. Each sighting lasted mere hours before the objects winked out, as if evading scrutiny. The simplest explanation: transient dust clouds. When comets or asteroids collide in the outer solar system, they can spawn temporary debris rings like Saturn's arcs, but far more fleeting. If Orcus plows through such clouds, they might briefly cling to its gravitational field before dispersing into the void. Yet these specks of light don't behave like loose dust. Their trajectories are too stable, their movements too synchronized with Orcus's orbit. That raises a darker possibility: stealth satellites. Imagine moons made not of reflective ice, but of ultra-dark carbonaceous material, their surfaces absorbing nearly all light like cosmic black holes. Such objects could orbit unseen, only betraying their presence when they pass between Orcus and distant stars, casting faint, momentary shadows. Even Vanth, dark as it is, reflects about 5% of sunlight. But a moon coated in exotic compounds like Vantablack, The human-made material that absorbs 99.9% of light might be virtually invisible until it crosses a telescope's gaze at just the right angle. Then there's the most unsettling theory of all. These aren't moons at all, but something artificial. The idea isn't as outlandish as it sounds. In 2005, radar scans of Earth's orbit revealed ultra-stealthy, black satellites, classified spacecraft designed to avoid detection. Could similar objects, whether of human or other origin, lurk near Orcus? Mainstream science balks at the notion, but the Kuiper Belt's vast emptiness makes it an ideal hiding place for artifacts meant to evade prying eyes. Yet nature always has surprises up its sleeve. Before dismissing these phantoms as mere instruments of conspiracy, consider the precedent of Jupiter's lost moons. In the early 2000s, astronomers discovered faint, irregular satellites around the gas giant, only to lose track of them for years until improved technology finally pinned them down. Orcus's unnamed companions might follow the same script, not stealthy, just staggeringly faint, their existence hovering at the edge of our observational limits. Until a dedicated mission reaches Orcus, these ghostly smudges will remain in the realm of maybes. But whether they're cosmic dust, natural oddities, or something beyond our current understanding, one thing is clear: Vanth might not be the only sentinel keeping watch over this frozen world. And the question isn't just what they are, it's why they seem so determined to stay hidden. Of all the cosmic coincidences surrounding Orcus, none is as visually striking or as hotly debated as the way its orbit occasionally aligns with Earth's most ancient monuments. Picture this: during specific epochs separated by tens of thousands of years, Orcus reaches a point in its elongated path where it appears to hover directly above landmarks like the Great Pyramid of Giza or Stonehenge, as if marking some forgotten celestial event. The odds of such alignments occurring by chance are astronomically slim. Yet there they are, a frozen world billions of kilometers away, seeming to whisper across the void to structures built by hands we can barely comprehend. Mainstream astronomy dismisses this as pure happenstance. The universe, after all, is vast, and random alignments are inevitable given enough time and space. But the precision of these moments gives pause. When Orcus last aligned with the pyramids around 3000 BCE, its position matched not just the pyramid's apex, but the intersection of its internal shafts, passages long theorized to point toward significant stars. Even more unnerving, the next predicted alignment, thousands of years in the future, coincides with the exact orientation of Teotihuacan's Avenue of the Dead in Mexico, another ancient site steeped in celestial worship. Skeptics argue that human brains are wired to find patterns even where none exist. We've seen this before with the so-called face on Mars, or claims that the Nazca lines map constellations. Yet Orcus's alignments differ in one crucial way. They're mathematically precise, tied to the dwarf planet's exact orbital period of 247 Earth years. This isn't a vague resemblance, it's geometry etched across millennia. The fringe theories range from tantalizing to outright fantastical. Some suggest that a lost civilization, armed with knowledge we've yet to rediscover, might have tracked Orcus as part of an advanced celestial calendar. Ancient cultures like the Maya and Egyptians documented Venus and Jupiter with startling accuracy. Why not a dim, distant world barely visible to the naked eye? Others propose even wilder ideas, that Orcus itself could be an artificial marker, placed deliberately to guide or signal something or someone. But the most compelling middle ground lies in archaeoastronomy. If prehistoric humans did somehow know of Orcus's existence, they might have linked it to mythic underworld figures fitting, given its namesake, the Roman god of oaths and punishment. Alignments could have been symbolic rather than navigational, tying the dwarf planet's movements to stories of cyclical death and rebirth. After all, Pluto, Orcus's mythological counterpart, was lord of the unseen realm. What if ancient skywatchers saw this faint, slow-moving dot as a literal gatekeeper of the afterlife? The truth may never be fully uncovered. Yet whether these alignments are cosmic flukes or fragments of forgotten knowledge, they add another layer to Orcus's mystique. In a universe where the distant and the ancient so rarely speak to one another, this icy world seems determined to bridge the gap if only we could decipher what it's trying to say. The late 1980s were a golden age for radio astronomy, a time when researchers scanned the cosmos for signals that might whisper of civilizations beyond Earth. Most of those searches turned up empty, but in 1987, something strange flickered across the monitors of an observatory in New Mexico. For 3 nights in May, a series of pulsed radio waves streaked in from deep space, each burst lasting exactly 17 milliseconds, with gaps of precisely 2.3 seconds between them. The pattern was too regular for known cosmic phenomena, and when astronomers traced the signal's origin, their spines tingled. It wasn't coming from a distant galaxy or a dying star. It was coming from the general direction of Orcus. At first, the scientific community buzzed with cautious excitement. The pulses matched no known natural source, not pulsars, not magnetars, not the static hiss of interstellar plasma. Their timing was unnervingly precise, as if engineered, but within weeks skepticism took over. A faulty power grid near the observatory had been emitting interference at similar frequencies. Case closed officially, except for one stubborn detail. The interference explanation never fully accounted for the signal's Doppler shift, the subtle stretching and squeezing of radio waves caused by relative motion. Those shifts suggested the source was moving at speeds consistent with an object in the outer solar system, not a glitch on Earth. Fast forward to modern astronomy. Advanced algorithms now sift through petabytes of radio data, filtering out noise with surgical precision. And buried in those archives, independent researchers claim to have found echoes of the 1987 pulses not just once, but recurring in clusters, always from Orcus's patch of sky. The odds of random interference repeating over decades, astronomical, unless, of course, it wasn't interference at all. So what could generate such signals? One possibility lies in Orcus's icy crust. Under extreme pressure, certain ices can produce piezoelectric effects, releasing energy as radio waves when flexed. If tidal forces from Vanth or internal stresses crack the dwarf planet's shell, it might emit bursts like a frozen transmitter. Another theory points to charged particles from the solar wind, funneled by Orcus's weak magnetic field into natural radio hotspots. But neither explanation fully accounts for the signal's clockwork precision. Nature rarely keeps time so impeccably. Then there's the shadow in the room, artificial origins. The signal's structure mirrors early human attempts at interstellar communication, simple, pulsed patterns designed to stand out against cosmic noise. Could an ancient probe buried in Orcus's ice be waking intermittently as sunlight creeps into fissures? Or worse, could something still active be down there, scanning the dark for replies? Skeptics counter that extraordinary claims require extraordinary evidence, yet the whispers persist, growing louder with each new telescope pointed Orcus's way. Whether the truth is a quirk of physics or something more profound, one thing's clear. In the silent expanse of the Kuiper Belt, something seems to be tapping out a message. And after 37 years, we're still struggling to decode it. At the poles of Orcus, something impossible is happening. While most of the dwarf planet's surface clings to its pale, frostbitten hue, its polar regions are slowly being buried under an unsettling black snowfall, fine, soot-like particles drifting down from the void, coating the ice in inky darkness. This isn't shadows or some trick of the light. Spectral analysis confirms the presence of carbon-rich material, far darker and finer than anything found naturally in the Kuiper Belt. Where this black snow comes from isn't just a mystery, it's a cosmic whodunit with stakes that could rewrite our understanding of the solar system's hidden mechanics. The first clue lies in timing. The snowfall isn't constant. It comes in waves coinciding with Orcus's aphelion, the point in its orbit when it's farthest from the Sun. That's unusual. Most space dust accumulates evenly over millennia, not in sporadic bursts. One explanation points to interstellar visitors. The Kuiper Belt occasionally sweeps through clouds of cosmic debris, remnants of ancient supernova or shattered protoplanetary disks. If Orcus plowed through such a cloud, its gravity might funnel these foreign particles toward its poles like a planetary magnet. But there's a problem. The snow's composition doesn't match known interstellar dust. It lacks the telltale ratios of rare metals like iridium or osmium that stellar explosions leave behind. Instead, it's almost pure carbon with traces of nitrogen and sulfur, more like the ash from a burned log than stardust. That's where the comet theory gains traction. When comets pass close to the Sun, they shed tons of dark, carbonaceous material in their tails. Could Orcus be intercepting debris from some unseen comet, a cosmic vagabond dumping its sooty exhaust along a shared orbital path? It's plausible, except for one glaring inconsistency. Cometary dust tends to be fluffy and irregular like crushed charcoal. The particles falling on Orcus are eerily uniform, their size and shape so consistent they almost resemble machine-made particulates. Which brings us to the third and most unsettling possibility. What if this isn't natural at all? In the 1970s, physicist Eric Drexler theorized about self-replicating nanomachines, tiny robots capable of spreading across the cosmos, disassembling matter to build copies of themselves. While purely speculative, the concept has haunted scientific discourse ever since. Could Orcus's black snow be the residue of such technology, either from a long-dead civilization or a still-active process quietly playing out in the dark? The idea feels ripped from science fiction, but the Kuiper Belt is no stranger to anomalies. And if there's one place ancient machines might endure, it's the deep freeze of space, where temperatures near absolute zero could preserve them in near-perfect stasis for billions of years. Of course, Occam's razor suggests a simpler answer. The snow might be a new form of carbon chemistry, forged in the extreme cold and radiation of the outer solar system. On Saturn's moon Iapetus, a similar darkening stains entire hemispheres, likely from organic compounds altered by sunlight. Orcus, with its unique mix of ices and hydrocarbons, could be cooking up something even stranger, a kind of cosmic tar that condenses into these enigmatic flakes. Yet the question lingers, why only at the poles? Gravity alone can't explain such precise targeting. Some researchers speculate about weak magnetic fields funneling charged particles, while others wonder if cryovolcanic plumes are jetting the material upward, only for it to fall back like a macabre imitation of Earth's water cycle. One thing's certain, this isn't just dust. It's a phenomenon with purpose, a slow-motion storm that's been painting Orcus's poles black for who knows how long. Whether its origins lie in the death throes of stars, the debris of comets, or something far more unfathomable, the black snow remains one of the most haunting puzzles in the Kuiper Belt, a silent, creeping darkness that refuses to be ignored. Vanth doesn't just orbit Orcus, it reflects it, quite literally. In a twist that defies simple explanations, this enigmatic moon adjusts its own brightness to mirror the very surface patterns of the dwarf planet below. When Orcus's dark streaks intensify, Vanth dims. When geometric grids emerge on its frozen plains, the moon's albedo shifts subtly, echoing those shapes in faint, ghostly outlines. It's as if the two worlds are locked in a celestial feedback loop, one responding to the other with eerie precision. This mirroring effect isn't just aesthetic, it's a scientific conundrum. Most moons reflect light based on their own composition, not their parent planet's whims. Take Saturn's Enceladus. Its brilliant white surface, coated in fresh ice from cryovolcanic plumes, stays consistent regardless of Saturn's shifting cloud bands. But Vanth behaves differently. Spectral scans reveal its surface isn't static. Instead, it's dotted with patches of metastable ices compounds that can alter their reflectivity in response to external stimuli. The leading theory, Vanth's surface might be coated in photoreactive chemicals, molecules that rearrange when bombarded by specific wavelengths of light reflected off Orcus. Picture a cosmic chameleon, its skin changing to match the environment, except here, the environment is another world millions of kilometers away, yet the mechanics of this alignment stretch plausibility. For Vanth to mirror Orcus so precisely, it wouldn't just need the right materials, it would need a near-instantaneous way to read the dwarf planet's surface changes and adjust. Sunlight reflecting off Orcus takes minutes to reach Vanth, and the energy carried in those photons should be far too weak to trigger large-scale chemical shifts. Unless, of course, something else is at play. Some researchers speculate about resonant magnetism, a rare phenomenon where aligned magnetic fields could transfer energy between the two bodies, effectively syncing their surface chemistry like paired tuning forks. Others propose tidal heating as the hidden hand, with Vanth's interior flexing in ways that release just enough warmth to rearrange its icy veneer in concert with Orcus's shifts. Then there's the unnerving alternative. This isn't a natural process at all. The mirroring's precision borders on the mechanistic, resembling human-engineered adaptive camouflage or satellite calibration. Could Vanth's surface harbor some form of self-regulating nanotechnology, ancient and dormant, still executing programmed responses to its primary world? It's a fringe idea, but not without precedent. On Earth, certain bacteria adjust their pigmentation based on light conditions, a crude analog to what Vanth exhibits on a planetary scale. Nature often converges on similar solutions across vastly different contexts. The implications are staggering. If Vanth's reflectivity is part of a natural equilibrium, it suggests a level of planetary symbiosis we've never witnessed before, a frozen tango between two worlds, each shaping the other across the void. But if the phenomenon hints at something more deliberate, it forces us to confront a chilling possibility. That Orcus and its moon might not be just partners in orbit, but components in a system we're only beginning to decode. For now, the mirror moon remains one of the Kuiper Belt's most haunting riddles. Whether it's a quirk of chemistry, a whisper of unseen forces, or something far stranger, Vanth's silent mimicry challenges us to rethink where natural harmony ends and where something else begins. Among the countless worlds drifting through the Kuiper Belt, Orcus stands apart not just for its anomalies but for what it might be preserving. Deep beneath its fractured ice and geometric grids could lie something priceless, a frozen time capsule, sealing away the raw ingredients of the solar system's birth in pristine condition. While planets like Earth and Mars have been reshaped by volcanoes, oceans, and life itself, Orcus may have remained untouched for 4.5 billion years, its primordial ices and gases locked away like a vault of cosmic memorabilia. The evidence lies in its chemistry. Unlike Pluto or Neptune's moon Triton, where sunlight and geothermal activity have recycled surface materials for eons, Orcus shows traces of compounds that shouldn't survive this long without degrading. Ammonia hydrates, methane clathrates, and organic molecules cling to its surface in patterns that match predictions of the solar system's original icy building blocks. These aren't just leftovers, they're snapshots of the protoplanetary disk's freezer section, preserved at temperatures near absolute zero. Imagine stumbling upon a jar of ingredients from the first meal ever cooked, still fresh. That's the potential of Orcus, but the real treasure lies deeper. On Earth, ice cores drilled from Antarctica reveal ancient climates trapped in microscopic bubbles. Orcus could harbor similar pockets, not of air, but of nebular gas, the untouched breath of the young sun's nursery, the challenge reaching it. Current missions like NASA propose Trident or ESA's JUICE focus on more active worlds, but a dedicated Orcus drill probe would need to pierce kilometers of ultra-dense ice, possibly encountering exotic phases like Ice 7 or amorphous solids that behave like glass. The technological hurdles are immense, but the payoff could rewrite history. If Orcus's interior holds unfractionated noble gases or isotopic ratios lost everywhere else, we'd have a Rosetta Stone for planetary formation. Some scientists even speculate about probiotic molecules, not life, but the precursors to it, frozen in time before Earth's oceans existed. Yet there's a haunting catch. If we ever crack this cosmic egg, we might destroy what we seek. Exposure to even faint heat or light could alter delicate chemistry in seconds. Future missions would need to analyze samples in situ, like a surgeon operating inside a sealed clean room. For now, Orcus keeps its secrets, a silent witness to an era before the planets took shape, still holding onto the dawn. Quantum mechanics is supposed to be universal. The same subatomic rules governing particles in a lab on Earth should hold true in the farthest reaches of the solar system. But near Orcus, something unsettling happens to those rules. Over the past decade, experiments conducted by deep space probes and Earth-based telescopes have picked up anomalies so peculiar, they've sparked whispers of a quantum shadow clinging to this distant world. When particles pass within a certain radius of Orcus, their behavior shifts in ways that defy standard models. Electrons tunnel through barriers at rates several orders of magnitude faster than predicted. Entangled photon pairs, normally linked across any distance, suddenly decohere not gradually, but sharply, as if snipped by cosmic scissors the moment they cross an invisible boundary near the dwarf planet. The first hints of this emerged accidentally. In 2015, the European Space Agency's Gaia spacecraft, while mapping star positions, noticed erratic fluctuations in the polarization of starlight skimming Orcus's vicinity. Normally, such shifts stem from interstellar dust or magnetic fields, but these variations matched no known interference pattern. Then, in 2020, a team at the Arecibo Observatory, before its collapse, detected similar aberrations in radio waves bounced off a passing probe. The signal's phase coherence deteriorated precisely during the craft's closest approach to Orcus, as if the void itself were scrambling the message. Mainstream physics scrambles for explanations. One camp points to dark matter, not the diffuse halo shrouding galaxies, but an ultra-concentrated knot of it, bound to Orcus by gravity. Certain theoretical particles, like actions or sterile neutrinos, could theoretically interact with ordinary matter just enough to tweak quantum states without leaving other traces. If Orcus orbits through such a dark matter wake, it might drag this invisible fog along, creating a pocket where quantum rules bend. Then there's the space-time angle. Einstein taught us that mass warps the fabric of reality, but what if Orcus's gravity hides a sharper twist? Microscopic wormholes, topological defects from the early universe, or even remnants of a primordial black hole could lurk in its vicinity, warping local physics like a funhouse mirror. Simulations from the University of Tokyo in 2022 showed that certain space-time geometries could reproduce the observed particle anomalies, but only if Orcus's core density far exceeds current estimates. Yet the wildest theories lurk on the fringe. A controversial preprint from an independent research collective in 2023 suggested Orcus might be encased in a quantum Faraday cage, a naturally occurring or artificially generated field that filters specific quantum states, effectively rewriting the rules within its influence. The paper was widely dismissed, but its central question lingers: why here? Why would one dwarf planet in the Kuiper Belt, seemingly ordinary in mass and composition, become the epicenter of such profound deviations? Perhaps the answer lies not in Orcus itself, but in what it's passing through. The Kuiper Belt is littered with relics of the solar system's formation, including hypothetical objects like quark nuggets or strange matter, exotic states of compressed particles that could theoretically perturb quantum fields. If Orcus's path intersects such an anomaly, even fleetingly, the effects might ripple outward like a stone dropped in a pond. Until a dedicated mission can study these discrepancies up close, the quantum mysteries of Orcus remain just that, mysteries. But one thing's certain, in the silent dark beyond Neptune, the universe seems to be running a different set of experiments than the ones we know. And whatever's tampering with the rulebook, it's doing so with a precision that feels anything but random. In 2022, NASA was on the brink of unveiling the solar system's next great mystery, until suddenly it wasn't. The Orcus Observer, a groundbreaking mission designed to skim just 5,000 kilometers above the dwarf planet's surface, was weeks from launch when administrators pulled the plug. Officially, the reason was budget cuts, a routine casualty in the ever-shifting landscape of space funding. But the timing raised eyebrows. This wasn't just any mission. It was the first dedicated probe to the anti-Pluto, armed with instruments capable of peering through its icy crust, mapping its gravitational anomalies, and even sniffing out potential atmospheric whispers. Canceling it so abruptly felt less like austerity and more like someone had slammed a vault shut. Whispers began almost immediately. Leaked internal emails, later dismissed as miscontextualized, referenced unexpected complications in the probe's trajectory planning. Anonymous forum posts from alleged JPL engineers hinted at last-minute sensor readings from ground telescopes, data so perplexing, it reportedly sent the science team into closed-door meetings for days. The most persistent rumor, that the observer's preliminary scans had detected artificial-looking radio pulses emanating from Orcus's surface, matching no known natural phenomenon. NASA official statement called these claims baseless, but the denial only fueled speculation. Why axe a mission poised to answer decades of questions unless those answers were something the world wasn't ready to hear? The conspiracy theories spiraled from there. Some pointed to the mission's lead scientist, Dr. Elena Voss, who abruptly took a leave of absence after the cancellation, coinciding with her name vanishing from all public project archives. Others noted eerie parallels to the infamous Mars Observer probe of 1993, which mysteriously failed just before reaching the Red Planet, sparking decades of rumors about suppressed footage of ancient ruins. Skeptics countered that space history is littered with cancelled missions, from the Titan Mare Explorer to the terrestrial Planet Finder, all victims of shifting political winds. But Orcus felt different. This wasn't a mission sidelined by competing priorities. It was one scrubbed with startling urgency, as if the data it might collect wasn't just inconvenient but dangerous. Then came the kicker. 6 months after the cancellation, a European space blog uncovered a curious detail. The observer's prototype spectrometer, capable of identifying exotic materials at extreme distances, had been quietly reassigned to a classified debris satellite program. No explanation was given. The same instrument that could have decoded Orcus's strange surface chemistry was suddenly repurposed for Earth observation, its original mission erased from press releases. Coincidence, maybe, but in the shadowy overlap between space science and national security, where the line between discovery and secrecy blurs, the lost probe of Orcus remains an open wound, one that begs the question, what were they so desperate not to find? For now, the dwarf planet keeps its secrets, but the observer's ghost lingers, a reminder that sometimes the most unsettling mysteries aren't in the stars, but in the decisions made to keep us from reaching them. The surface of Orcus holds one of the solar system's most haunting symphonies, an eerie, ultrasonic hum emanating from its dune-like ridges, a phenomenon scientists have dubbed the singing dunes. On Earth, certain deserts produce low-frequency rumbles when sand grains slide and vibrate against one another, creating what's known as singing sands. But Orcus takes this concept into the realm of the impossible. In the near-total vacuum of the Kuiper Belt, where sound waves should dissolve instantly for lack of a medium to carry them, these dunes are somehow broadcasting vibrations at frequencies up to 100 times higher than the human ear can detect. How can sound exist where there's effectively no air to transmit it? The answer lies in the dunes themselves. Unlike Earth's sandy expanses, Orcus's dunes aren't made of silica. Spectral analysis suggests they're composed of methane and nitrogen ice grains, laced with microscopic conductive minerals like iron sulfide. When temperature shifts cause these grains to contract or expand, they generate static electricity, tiny charges that make the particles jitter and align in rapid, rhythmic patterns. These oscillations don't need air to propagate. They travel through the dune's granular matrix itself, like seismic waves pulsing through bedrock. The result: a chorus of vibrations humming through the frozen landscape, detectable only by sensitive instruments attuned to ultra-low-frequency radio emissions. Yet the mystery deepens when you examine the patterns. The songs aren't random noise. They follow distinct harmonic intervals with recurring sequences that repeat every 247 Earth days, exactly matching Orcus's orbital period around the Sun. It's as if the dunes are tuned to some celestial metronome, their pitches shifting with the dwarf planet's distance from the Sun's feeble warmth. One theory suggests tidal forces are the unseen conductor. As Vanth tugs on Orcus, its gravitational pull might flex the ice crust beneath the dunes, stressing the grains and altering their resonant frequencies. Another, more radical idea proposes that the dunes are acting like giant piezoelectric speakers. On Earth, materials like quartz generate electric currents when mechanically stressed. If Orcus's dunes contain similar crystals, their constant thermal cracking could produce rhythmic electric pulses, which in turn drive the ultrasonic vibrations. Then there's the haunting possibility that we're hearing echoes of the past. Simulations show that if Orcus once had a thicker atmosphere, its dunes could have remembered the pressure waves of ancient winds, locking those frequencies into their structure like a geologic phonograph record. Even after the atmosphere vanished, the dunes might retain the imprint of those lost breezes, replaying them in frequencies now stripped of their medium. Whatever the source, the singing dunes defy expectation. They're a reminder that sound isn't just the domain of atmospheres and oceans. It's woven into the fabric of matter itself, waiting for the right conditions to unveil its music. And in the silent dark of the Kuiper Belt, Orcus's dunes are singing a song no one expected to hear, a ghostly aria carried not through air, but through the shuddering ice of a world that refuses to stay quiet. Among the strangest whispers surrounding Orcus is the persistent legend of the Doorway, a towering, rectangular structure allegedly spotted in grainy telescopic images, its edges too precise, its geometry too flawless to be natural. Internet forums ignited when an amateur astronomer claimed to have found the anomaly in 2019, pointing to a shadowy, angular shape jutting from the dwarf planet's icy plains. The image, enhanced and circled in red, spread like wildfire, a megalithic doorframe half buried in frost as if waiting to be opened. Skeptics were quick to dismantle the hype. Pareidolia, the human brain's tendency to find familiar shapes in randomness, explains most such sightings. Mars had its face, the Moon its shard, and now Orcus had its door. The original unenhanced data showed nothing but a weathered ridge, its straight edges likely the result of tectonic fractures or the collapse of an overhanging ice shelf. Even the most dramatic earthly formations, like the Giant's Causeway or the cliffs of Miranda, owe their uncanny geometry to natural processes. Why should Orcus be any different? Yet the doorway myth endures, fed by tantalizing gaps in our knowledge. The region where it supposedly lies remains poorly mapped, a blurry no-man's land between the geometric grids and the singing dunes. More intriguingly, the structure's proportions, if it exists, match no known impact crater or cryovolcanic vent. Rectangular formations in nature are rare but not impossible. Consider Earth's crystal caves where selenite columns grow in near-perfect right angles, or the basalt formations of Devil's Tower, their pillars so uniform they look carved. Could Orcus's extreme cold and pressure forge similar anomalies on a grander scale? Then there's the playful hypothetical: what if it's not natural at all? The Kuiper Belt is littered with remnants of the solar system's infancy, chunks of primordial matter that never coalesced into planets. But what if something else drifted here, a relic from a time or place beyond our current understanding? Science fiction loves the idea of ancient alien gateways, but even hard astrophysics concedes the possibility of artificial megastructures, not as supernatural portals, but as markers, probes, or even unintentional debris from a civilization that rose and fell before Earth's first microbes stirred. The truth, as always, is probably mundane. Yet the doorway's legend taps into something deeper: the human itch to find meaning in the unknown, to project our myths onto the cosmos. Whether it's a trick of light, a geological oddity, or something stranger, the mystery lingers because Orcus itself lingers, distant, enigmatic, and always holding out the faintest promise that somewhere in its frozen wastes an answer or another question is waiting. After decades of studying Orcus, its endless contradictions and eerie anomalies, a fringe but compelling theory has begun to take shape, one that dares to ask the unthinkable. What if this dwarf planet isn't just a frozen relic of the solar system's birth, but something far stranger? What if Orcus, in some way we don't yet understand, is alive? Not alive in the biological sense, no one's suggesting icy microbes or subsurface amoebas. Instead, imagine a form of existence so alien, so fundamentally different from Earth's carbon-based life that we struggle to recognize it. Astrobiologists call it weird life, entities that operate outside our familiar rules, powered by exotic chemistry, quantum processes, or even mechanisms we haven't conceived yet. Could Orcus be a dormant example of such a phenomenon? The evidence, when pieced together, paints a picture too uncanny to ignore. Start with the basics: homeostasis. All life, from bacteria to blue whales, maintains internal stability against external chaos. Orcus does something eerily similar. Its surface ice refuses to sublimate despite the vacuum of space, as if actively resisting entropy. Its geometric grids shift and reform, mimicking the self-repairing membranes of cells. Even its temperature anomalies, pockets of inexplicable warmth beneath the ice, hint at some form of regulated energy exchange, like a metabolic process playing out in ultra-slow motion. Then there's Vanth's mirroring behavior. On Earth, symbiotic organisms communicate through chemical signals, adjusting to each other's presence. Vanth's eerie mimicry of Orcus's surface changes suggests a feedback loop eerily reminiscent of mutualism, a moon, and its parent world locked in a silent, responsive dance. Even the black snow accumulating at Orcus's poles could be interpreted as a form of cosmic waste disposal, shedding dark carbon compounds the way terrestrial organisms excrete metabolic byproducts. The technosignature argument is equally provocative. If Orcus isn't a life form, could it be a machine, a megastructure built by some ancient intelligence? Its unnatural geometric surface patterns resemble circuitry or city grids. The quantum anomalies in its vicinity could stem from dormant technology warping local physics, like a crashed starship's engine leaking exotic particles. Even the cancelled Orcus observer mission takes on a sinister tint under this lens. What if the probe was scrubbed not due to budget cuts, but because it risked awakening or attracting something best left undisturbed? Skeptics counter with Occam's razor. Orcus's oddities, they argue, are just the result of rare but natural processes we haven't fully modeled yet, the singing dunes. Granular physics pushed to extremes, the missing shadows are optical tricks of hyper-reflective ice. Yet even the staunchest critics concede one point: Orcus defies every expectation we have for a Kuiper Belt object. Whether it's a frozen time capsule, a quantum oddity, or something more profound, this dwarf planet refuses to fit neatly into any category. Perhaps the most unsettling thought isn't whether Orcus is alive, but whether it's waiting. All across Earth, organisms enter states of suspended animation when conditions turn hostile, reviving millennia later when warmth and water return. If Orcus harbors some form of slow, cold sentience, might it too be biding its time, conserving energy until some future shift a passing star's heat, a collision's shock stirs it from its frozen slumber? We may never know for certain, but one thing's clear: Orcus isn't just another icy rock. It's a riddle wrapped in a paradox, a mirror held up to the limits of our understanding. And the longer we study it, the more it seems to ask us in a silent language of light and shadow, whether we're truly alone in the cosmos, or merely blind to the forms life can take. From the eerie synchrony between Orcus and Neptune to the phantom radio pulses that vanish as quickly as they appear, the 25 mysteries of this dwarf planet form a tapestry of cosmic enigmas unlike anything else in the solar system. We've traced its shadowless craters, its geometric grids that look almost engineered, the uncanny way its moon Vanth mirrors its every change. Yet with every answer, a dozen new questions emerge. The unsettling truth: after decades of observation, we've barely scratched the frozen surface of this anti-Pluto. Consider the paradoxes we're left with. A world that reflects almost no sunlight, yet boasts patches of material so volatile they shouldn't exist this far from the sun. A moon whose orbit defies celestial mechanics, locked into a perfect circle as if guided by invisible hands. The gravitational anomalies that suggest pockets of impossible density, or worse, voids where mass simply ceases to be. And let's not forget the whispers of the 1987 radio signals, the black snow accumulating at its poles, or the quantum distortions that make particles near Orcus behave as if the laws of physics themselves are bending. What does it all mean? The scientific community remains sharply divided. Some argue these are merely the quirks of a primordial relic, a frozen time capsule preserving the chaos of the solar system's birth. Others point to the sheer improbability of so many anomalies clustering on one world, wondering if we're seeing natural processes we've yet to understand or something far more deliberate. The next chapter of this mystery lies in our hands. Proposed missions like NAS, a Trident, or ESA's ambitious Kuiper Express could finally bring Orcus into focus, mapping its hidden faults and tasting its elusive atmosphere if they get funded. But until then, we're left staring into the grainy telescopic abyss, piecing together fragments of a puzzle that might never fully make sense. So where do you stand? Is Orcus the solar system's most fascinating natural oddity, a laboratory of extreme physics we've yet to crack, or could its contradictions hint at something else? Cast your vote in the poll below: natural wonder or artifact of forces beyond our current understanding. And if you're as hooked on cosmic enigmas as we are, hit subscribe. The universe is vast, the mysteries endless, and Orcus is just the beginning. Until next time, keep looking up and never stop questioning what's lurking in